Okay, good morning all. So this is a new lectures for us where we have gathered listen about this oxidation and uh, reduction mechanisms or reactions. Basically, in organic chemistry, as I used to say, there are four types of the reactions: substitution, addition, elimination, and rearrangement. These are four major types of the reactions, and some reactions are there which cannot be categorized into this category. So fifth class of reaction is termed as this oxidation and redox reduction, basically abbreviated as redox reaction. Read, that stands for redox or reduction, and ox, basically it stands for, let us say, oxidation. So in this regard, we are going to refer the basics of oxidation, reduction reactions. What are these basics behind this? So we'll study this in the present lecture or present discussion. I have taken my content from this organic chemistry, Paula Bruis, P.Y. Bruis, and that is chapter number 20 of this redox reactions, oxidation and reductions. So this redox reactions in organic chemistry, we are going to refer that how an organic compound is oxidized, how an organic compound is reduced. As you know that physically most of the carbonyl compounds, they are prone to undergo reduction and may form alcohol. So firstly, let us learn what is called redox, what is called oxidation reduction. Oxidation is always coupled with the reduction. I mean to say, whenever any substance undergo oxidation and parallelly, same another substance may undergo reduction. Oxidation and reduction, both such kind of reaction will always occur parallelly. Say one substance is being oxidized, other substance is being reduced. Both occur in simultaneous manner in a parallel fashion. Loss of electron, basically termed as oxidation. Whenever a substance releases the electron, this process is called as oxidation. Contrary to this, if a substance receives the electron, process is called as reduction. One substance is donating, so it is being oxidized. Other substance is receiving, so that's why it is reduced. So naturally, likewise, money. If you pay the money to the shopkeeper, you are being oxidized. And shopkeeper is receiving the money, so shopkeeper is reduced. So that way, oxidation and reduction. A substance giving the electron, so it is oxidized. A substance is receiving the electron, so that's why it is reduced. Okay, so in terms of electron, we can categorize oxidation and reduction. The same definition can be termed by oxygen also. Addition of oxygen is called as oxidation. Whenever there is a reaction, there is addition of oxygen, so it is termed as oxidation. And similarly, removal of oxygen is also called as reduction. Oxygen का addition is oxidation, oxygen का removal is reduction. Same definition we can also give in terms of hydrogen. Addition of hydrogen is termed as reduction, and removal of hydrogen is termed as oxidation. We have to mind the difference very well. Electron ka addition is basically reduction. Electron ka loss, that is oxidation. Oxygen ka addition is oxidation. Oxygen ka removal is reduction. Hydrogen ka addition, reduction. Hydrogen ka removal will become this way. These reductions and oxidations are. एक और definition भी है. Definition तो नहीं, but एक concept. Increase in oxidation number is termed as oxidation, and increase in oxidation number is termed as reduction. That way we can give the fourth definition of oxidation reduction. तो बस याद ये रखना है कि कौन सा सब्सटेंस है और क्या इसके एडिशन पे क्या होगा, रिडक्शन पे क्या. All these terms basically correlate with each other through the process of redox reactions. The oxidation state of a carbon atom equals the total number of CO, CN, and CH bonds. These are the reactions, or we can call the oxidation states for many other substances. So have a look at a glance for a minute, then we'll explain what is the meaning of this, which is called oxidation and reduction. So redox reactions, oxidation levels as shown over here, 1, 2, 3, and 4. For methane, CH4, this is given as 0. For methanol, dimethyl ether, methylamine, chloromethane, it is 1. Why it is 1? Because आप इसमें देखोगे Cl minus, उसका उल्टा दो +1. Oxidation state is +1. This aldehyde having hydride, 2 H minus are there. So ulta do, it will become +2. Carboxylic acid, this ester, methyl ester. And to the oxygen itself 2 and OH minus ka -1. So -3. Overall molecule is 0. That's why it is having +3. Acyl chloride. So here it is having -1, -1, or oxygen itself -2. -1, -1, -2, total -4. Overall molecule is 0. So carbon ka oxidation number is +4. So oxidation level or oxidation number of carbon and other atoms. They says that reduction at the carbon is basically decreases the oxidation number, and oxidation means like oxidation of a carbon means that decreases the number of CH bond, but also ulta do to increase in number of oxidation number. So in one short, reduction is decrease in oxidation number, and in oxidation is basically increase in oxidation number. hydrogen addition. You can see on this slide. If we have an alkene, and if we add the hydrogen, it's like an addition reactions. In presence of palladium charcoal, and this what we used to call at ethane will be formed. Addition of hydrogen is basically called as reduction. If we add hydrazine NH2NH2 to a keton RCOR, then it will form this substance methane, dialkyl methane, or we can call as a reduced ketone, that is alcohol. Aldehyde, if it is reacted with sodium borohydride is a powerful reducing agent. White colored substance, granular one, and very much sensitive to moisture. It will absorb the moisture. If it is reacted with any aldehyde, it will reduce the aldehyde to alcohol. This way, hydrogen, sodium borohydride, and hydrazines are reducing agents, which can reduce this substance upon addition of hydride H minus. What are the oxidizing agents? Bromine and perchloro, this hypochromic acid, H2CrO4. These are oxidizing agents. Likewise, bromine will see this. A symmetrical alkene reacts with symmetrical bromide. Light will form 1,2-dibromoalkane. Aldehyde is reacted with H2CrO4. So aldehyde is converted into carboxylic acid. Look at this previous slide. Aldehyde upon reduction form alcohol. On this slide, aldehyde upon oxidation forms carboxylic acid. ये जो दूसरा ऑक्सीजन कहां से आया aldehyde के पास? That is from this chromic acid. Oxidizing agent performing oxidation. Hope this is clear. Addition of oxygen is called as oxidation. Addition of hydrogen, कहाँ hydrogen add हुआ है? Carbonyl carbon के ऊपर. That's why now it is formed alcohol. And look at this. If we oxidize alcohol, तो क्या होगा? Upon oxidation of alcohol, it will form ketone. क्यों? क्योंकि removal of hydrogen is also termed as oxidation. Look at this. There were two hydrogen, but perchromic acid has removed these two hydrogens. So now it has formed ketone. Removal of hydrogen is termed as physical. Hydrogen is a powerful reducing agent. This exists in the form of gas at a room temperature. And it can be stored physically in cylinders. In a cylinder, these gaseous molecules are stored. What is a component of hydrogen? So generally we know that one hydrogen atom is bonded with other hydrogen atom. There is a bond between these two. Basically it is covalent bond. Bond which is formed by the sharing of electron. The two hydrogen atoms are connected with each other. If we add the hydrogen reduced to palladium charcoal, it will act as a powerful reducing agent. Palladium charcoal. Charcoal is nothing but Gujarati, we used to call it as kolso. That charcoal. We can also consider hydrogen as a mixture of two electrons and two protons. H plus, along with there are two electrons. Why it is termed as H plus? H plus is having only one proton in the centroid of nucleus. That's why it is a proton. आप एक H plus ले लो, दूसरा minus electron ले लो. So H plus and minus, overall H like this. H plus and minus, overall H can form the bond. So if we consider the hydrogen as a two protons, two electrons. So another reaction is there, which is called as dissolving metal ammonia reduction. See these reactions in slides. Another option is we can reduce the hydrogen as a H plus and H minus. What is that? H plus is a proton, H minus is a hydride ion having two electrons with one hydrogen. H minus and H plus, overall charge is 0, atom is hydrogen. So this can be utilized in the reduction using lithium aluminum hydride and sodium borohydride. Third reaction is also there. We'll visit all these reactions one by one, where hydrogen is used as a reducing agent. Let us first learn this reaction called hydrogen on palladium charcoal. Reduction by catalytic hydrogenation. As you refer hydrogenation, if we dissect this word, there are two terms, hydrogen and addition. Addition of hydrogen is basically called as this hydrogenation. Addition of hydrogen. Oxidation is addition of oxygen. Hydrogenation is addition of hydrogen. One butene that is exists in the form of gas. Hydrogen that is also gas. So you can imagine when a gaseous molecule reacts with the gaseous molecule, what will be the reaction vessel? Naturally, a closed vessel where for a gas, pressure is the concentration. Pressure, that is the concentration for a gaseous molecule. So if we control the pressure, then we can perform hydrogenation. Look at this reaction where one butene is added to hydrogen gas. It is forming butane. One pentation carbon-carbon triple bond containing compound reacted with hydrogen gas. This time not only one equivalent of hydrogen, but two equivalents of hydrogen are used. That is forming pentane. In this manner, this is being. If we take simple 2-butene and we use Lindlar catalyst, that is involving palladium, calcium carbonate, Lindlar catalyst, and hydrogen gas. This will form cis. This is a difference. Look at this. If we use palladium charcoal or platinum oxide, alkyne is directly reduced to alkane. If we use Lindlar catalyst, alkyne carbon-carbon triple bond containing compound is reduced to carbon-carbon double bond containing compound. That is this cis-2-butene. And friends, stereochemistry is also obtained selectively. This alkene we obtain, that is having cis geometry. Cis means, you know very well, that if these two hydrogens are present on the same side of double bond, is termed as cis. So, linear catalyst is a specific mechanism where the hydrogen atoms are added across the single side of the atom. Right? दोनों हाइड्रोजन एटम सेम साइड से ऐड होंगे, so these are basically termed as cis to beauty. एक हाइड्रोजन ऊपर से आएगा, एक हाइड्रोजन नीचे से आएगा, so that way it will form trans. Linear catalyst is much specific to yield stereo isomer selectively. This way, reduction is there. On the only alkene substituted benzene is we can also use with the help of this palladium charcoal. Reduction of benzene is not easy. Let me share you how. You know that benzene is a substance which contains carbon-carbon single bond and carbon-carbon double. This carbon-carbon single bond and carbon-carbon double bond undergo isomerization frequently. If we have hydrogen and palladium charcoal, so this will reduce only carbon-carbon double bond. They are present outside of the ring, but inside the ring there will be no change. Because this benzene ring is difficult to reduce because it is stable enough to resist the reduction. If it is not, let us say if it is oxidized or if it is reduced, तो क्या होगा? It will lose its aromaticity. Benzene के लिए उसकी aromaticity is everything. Similarly, if this benzene ring is difficult to reduce, but carbon-carbon double bond can be easily reduced. This hydrogen gas can also be used to reduce carbon-nitrogen double bond, carbon-nitrogen triple bond to carbon-nitrogen single bond. Let us take this imine where carbon is doubly bonded with nitrogen. Palladium charcoal reduction will make this methyl propyl amine. If we take this isobutyl propanenitrile, you can call it 2 moles of hydrogen gas because now this is triple bond. Vanny nickel is a specific nickel catalyst to reduce the carbon-nitrogen triple bond, carbon-nitrogen single bond, all as amine. So double bond का reduction करोगे तो क्या single bond और triple bond का reduction करोगे तो भी carbon-nitrogen. Not only for carbon-carbon double bond, carbon-carbon triple bond, the same catalyst can be used for carbon-nitrogen double bond, carbon-nitrogen triple bond, and for that reduction. We can also reduce alcohol, carbonyl compounds. There are lots of carbonyl compounds. Aldehyde, ester, ketone, carboxylic acids, anhydrides, acyl chlorides, amides, and many others. Majority of the functional group I have uttered just. These are all carbonic compounds, carbonyl derivatives, having carbon-oxygen double bonds. If we take aldehyde, having which is generally in which carbonyl is connected with hydrogen and one alkyl group. So upon reduction with hydrogen gas, nickel, it will form primary alcohol, which alcohol containing carbon is connected with only one carbon. That's why it is primary carbon, primary alcohol. If we take ketone, then ketone, the same reaction, now it will form secondary alcohol, where hydroxyl group containing carbon is connected with other two carbons. That's why it is secondary alcohol. Isopropanol, just similar kind of this. What is this? Nickel. It is a powerful catalyst to reduce. You know the definition of catalyst? I hope so. Catalyst is a substance which does not take part in the, which does not consume in the reaction, will take part in the reaction, and at the end of the reaction, it will be generated as such. If nickel is as such, although it may catalyze the reaction, but may be generated in the end. एक पहले वो एक मॉलिक्यूल को रिड्यूस करेगा, प्रोडक्ट बनाएगा, रीजनरेट होके दूसरे मॉलिक्यूल को फिर से वो रिड्यूस करता जाएगा. That way, this will work. Any of the catalyst, they further increases the activation energy. It is the minimum amount of energy required to promote the reaction. That is called activation energy. So these are all catalysts. Lindlar catalyst, nickel, platinum charcoal, platinum oxide, they are catalysts. Catalyze the reaction, increases the rate of the reaction. For you people also, examination is a kind of catalyst. मानो कि कल आपका GTU एग्जामिनेशन है, एक्सटर्नल एग्जामिनेशन, तो क्या करोगे आप? घूमने फिरने जाओगे या फिर पढ़ाई करने बैठोगे? पूरा एक घंटा पढ़ाई करोगे कि पूरा दिन पढ़ाई करोगे? नेचुरली आप पूरा दिन ही पढ़ाई करोगे क्योंकि सिलेबस ज्यादा होता है. So examination is a kind of catalyst for you. और मानो कि कल छुट्टी का दिन है, तो क्या फिर पूरा दिन पढ़ाई करोगे, एक घंटा पढ़ाई करोगे कि घूमने फिरने जाओगे? बोले आप, यू कैन से दैट सर घूमने फिरने जाएंगे. तो बोलो कौन सा कैटलिस्ट है which can increase the speed of your reading? Examination. So let us take examination not as a pressure, not as a just to get the marks. Let us take the examinations as to build ourselves, to learn something, to get something. The catalyst here is also a similar kind of this, which increases the rate of the reaction. जो रिएक्शन कंप्लीट होने में एक हफ्ता लगता था, कैटलिस्ट लेने से एक घंटे के अंदर within an hour reaction is completed. That is called the power of catalyst. Another name, we will visit several reactions which are oxidation reductions for organic compounds. One of such reaction is Rosenmund reaction. Friends, this Rosenmund reaction is basically reduction of acyl chloride to aldehyde. So you will visit the organic compounds where one organic compound is converted into other organic compound and it is having different features. Acyl chloride to aldehyde, where a partially deactivated palladium is taken. यहाँ पे this is reduction. We can prove इसका जो कार्बन का ऑक्सीडेशन स्टेट है that is -2, -1, -3. Overall molecule is 0. That's why carbon का oxidation charge is +3. Oxidation number, oxidation level. इसमें कैलकुलेट करो तो -2, -1, -3, +3. बट फिर भी इसको बोला ऑक्सीडेशन नंबर 3, दोनों जगह 3 ही है, पर यहाँ पे हाइड्रोजन का एडिशन हुआ है इसलिए उसको बोला है रिडक्शन। एंड वो हाइड्रोजन कहाँ से आया है? वो हाइड्रोजन आया है हाइड्रोजन गैस में से। Rosenman reaction is a kind of reaction where we can convert this carboxylic acids to this. If we take Raney nickel and try to reduce carboxylic acid, any ester, any amide, there will be no reaction. Reaction will not undergo if we take this. Okay. But if for the reduction of this, some other substances are utilized. Why these reactions are not undergoing? Because there is a necessity that we need to change the catalyst. How? Let us say, if Dr. Tejas M. Dhamelia is asked to teach pharmacotherapeutics, will I be able to teach pharmacotherapeutics? No. Because I have no expertise in pharmacotherapeutics. But if I am asked to teach organic chemistry, medicinal chemistry, computational chemistry, inorganic chemistry, pharmaceutical analysis, I can teach such topics. I can deal with these topics because that is my expertise. This catalyst cannot catalyze such reactions because these are not the perfect substrate for such catalyst. इसीलिए catalysis is basically a choosy reaction. जो कैटलिस्ट जिस सबस्ट्रेट के साथ डील कर पाता है वही रिएक्शन हो जा सकती है, otherwise it cannot go. Now, so these are all reactions which we visited if we consider the hydrogen as a component of two hydrogen atoms having one electron. These are all addition of hydrogen gas. Now, second type of reaction we'll visit, where hydrogen is considered as two protons, two electrons, which is basically a more important reaction in organic chemistry, called as, let us say, this one, dissolving metal ammonia reduction. Now, where are we? We are here. But hydrogen is considered as a proton, as an electron, as it is mentioned over here. It is specifically for reduction of alkyne and alkenes. You can see that there was especially for alkyne, in this case it is shown. If we take sodium metal or lithium metal, you know sodium is the only metal which can be cut easily with the help of knife. You have performed some experiments in identification of organic compound in pharmaceutical organic chemistry lab. You have taken the sodium metal. Very well know that this metal is much sensitive to moisture and water. सोडियम का एक पीस पानी में डालोगे ना तो आग लग जाएगी. It will catch fire. When we are putting a reaction with sodium metal, so we should take care. If I share one of the incident with when I was in M-Pharm, so one of my friend, he was dealing with sodium metal, and as a small piece of sodium metal that spilled and went to its eyes, where corneal fluids, lacrimal fluid also contain water. अब सिंपल सोडियम के पीस को पानी में डालते हो तो धमाका होता है, तो जो छोटा सा पीस आंख में जाएगा तो क्या हो सकता है? આંખમાં ક્યારેક કણું પડી જાય તો કેટલું પેઇન થાય એ ખબર છે. હવે સોડિયમનો ટુકડો અંદર જતો રહે તો કેટલું પેઇન થાય. तो थोड़े ही टाइम पे उसकी आंखें लाल हो गई, आंखें भी लाल हो गई, चेहरा भी लाल हो गया. And immediately he went to consult a doctor. What should do? Although he has washed his eye with plenty of water to remove the sodium metal. Luckily, his eye was saved. No harm to him. For 1 or 2 days, he has to take the relax at hostel. This way, when we are dealing with such metal, we should take care. आप हैंड ग्लव्स पहनो, मास्क पहनो, एप्रन पहनो, कैप पहनो, स्पेक्टिकल्स भी पहनो, so that we can prevent the exposure of our eye to any this hazardous material, dangerous material. So this metal reaction is like this. This reaction is called as dissolving metal ammonia reduction because first sodium metal is dissolved in ammonia. That is अमोनिया गैस होता है, बट उसको वाटर में डिसॉल्व करो तो अमोनियम हाइड्रोक्साइड बन जाता है, लिक्विड अमोनिया. इसलिए this reaction is basically called as dissolving metal ammonia reduction. If we take 2-butene, try to reduce this, it will form trans 2-butene. समझ में आ रहा है कि अब क्या होगा, एक हाइड्रोजन का एडिशन एक साइड से होगा, दूसरा हाइड्रोजन दूसरी साइड से आएगा, तब जाके आपका यहाँ पे ट्रांस प्रोडक्ट बन जाएगा. दोनों सेम साइड पे आते हैं तो बेसिकली इट इज कॉल्ड एज सिस 2-butene. तो एक प्रोटॉन का एडिशन एक साइड से, दूसरे प्रोटॉन का एडिशन दूसरे साइड से, फिर इलेक्ट्रॉन डोनेशन, दैट इज dissolving metal ammonia reduction. If we have a substance like this, which contains alkene and carbon-carbon triple bond, it will form 2 carbon-carbon double bonds. So in thus, dissolving metal ammonia reduction can occur. Reduction of a hydride, look at how it is added to alcohol. Upon addition of alkyl, this always, as I used to say, from source to deficiency, ये ऊपर जाएगा, माइनस चार्ज आ जाएगा, बॉन्ड बन जाएगा, और फिर H+ का एडिशन कर दो तो अल्कोहल बन जाएगा. अल्कोहल इज ऑलवेज वाटर सॉल्युबल. Hydronium ion is added. This way, the reactions of these things are easier. Now we are referring to third most type of mechanism, that is we have seen how the hydrogen gas is added, dissolving metal ammonia reduction. Now we will see the hydride ion and their addition. Third type of reaction where H2 can be used as a reducing agent. So what is that? Basically this. Aldehyde, ketone, and acyl chloride. And if they undergo similar kind of reduction, sodium borohydride, powerful reducing agent, it will form alcohol. Simply इतना ही है, येलो पोर्शन देखोगे तो पता लग जाएगा, बाकी जो सब्स्टिट्यूशन से ऐसे ही रखो, कीटोन का अल्कोहल बना दो बस. जहाँ पे भी कीटोन है, CO बॉन्ड C डबल बॉन्ड हो, उसको CHOH कर दो, CHOH. अल्डिहाइड है तो प्राइमरी अल्कोहल, कीटोन है तो सेकेंडरी अल्कोहल, असाइल क्लोराइड है तो प्राइमरी अल्कोहल. क्यों? क्योंकि यहाँ पे आप जैसे ही CHOH करने जाओगे ना, Cl भाग जाएगा. क्यों ऐसा होता है? क्योंकि एक ही 2 कार्बन पे जब हाइड्रोजन भी है, क्लोरीन भी है, तो that kind of substance is unstable. अब नेचर में कोई भी ऐसा कंपाउंड आपको नहीं मिलेगा जिसमें कार्बन इज कनेक्टेड विद हेलोजन द सेम वे इट इज कनेक्टेड विद OH. हेलोजन हैपेंस टू बी इलेक्ट्रॉन विड्रॉइंग ग्रुप, OH हैपेंस टू बी इलेक्ट्रॉन डोनेटिंग ग्रुप. ऐसा कोई सब्सटेंस है तो उसको अल्फा हेलोहाइड्रीन के नाम से बोला जाता है, उसको नाम दिया गया. ऐसा कोई सब्सटेंस आपको नहीं मिलेगा. बीटा हेलोहाइड्रीन आपको मिल सकता है, अल्फा हेलोहाइड्रीन नहीं मिल सकता है. Okay, so this way, hydride H minus and one you can consider H plus proton. So it is used. H minus is present in sodium borohydride, H plus is present in hydronium ion. This way, these three types of reactions are there. अब sodium borohydride का भी बाप, I mean to say, more powerful reducing agent, the universal reducing agent is lithium aluminum hydride. Stronger this reducing agent, which is able to reduce any of the substance. कार्बोक्सिलिक एसिड है, उसका रिडक्शन करो तो अल्कोहल. एस्टर है तो उसका रिडक्शन करो तो अगेन प्राइमरी अल्कोहल. When sodium borohydride is not giving the reaction, we can use this lithium aluminum hydride. Is universal reducing agent. किसी को भी reduce कर देगा. एस्टर को, कार्बोक्सिलिक एसिड को, इवन अमाइड को भी can reduce. Dibal. This is basically lithium, sorry, not lithium, but aluminum diisobutyl lithium aluminum hydride. तो वो जो diisopropyl aluminum hydride, not lithium, but aluminum. Isopropyl group, functional group. And what is it? It is selectively used to reduce ester to aldehyde. Yes, here it can reduce ester to aldehyde. अब पीछे देखो तो lithium aluminum hydride can reduce ester to alcohol, or lithium this diisobutyl aluminum hydride can use ester dibal that can be used to ester to aldehyde. You have seen one of the reaction called Rosenmund reaction, where acyl chloride was reduced to which substance? If you go to the few black slides, we have used Rosenmund reaction, acyl chloride to aldehyde. अब acyl chloride का reduction करना है, again aldehyde, then this lithium aluminum this isobutoxy, कौन सा है, CH3 tertiary butoxy hydride. So that is used. That is parallel to this Rosenmund reaction. And next is reduction of amine. As I told you, वो amide को भी reduce कर सकता है. Amide को reduce करोगे तो amine बन जाएगा. जैसे एक ही कार्बन पे OH और Cl प्रेजेंट नहीं रह सकते, सिमिलरली इसी का एक कार्बन पे OH और NH2 प्रेजेंट नहीं रह सकते. OH और H plus और H3O plus बना के वाटर मॉलिक्यूल बना के वो निकल जाएगा. Simply it will form this. If you have primary amide, it will form primary amine. If you have secondary amide, then it will form secondary amine. If you have tertiary amide, then it will form tertiary amine. तो ये बहुत ध्यान में रखना है कि कौन सा reagent, कौन सा substance क्या होता है. This may be asked during some of the MCQs or other these things. Dibal ester to aldehyde, Rosenmund ester to acyl chloride to aldehyde. If we reduce the alcohol, if we reduce, let us say, aldehyde, primary alcohol. If we reduce the ketone, secondary alcohol. If we reduce tertiary amide, then it will form tertiary amine. Yeah, this maybe we can learn. Sodium borohydride is selectively also used to reduce aldehyde, but it will not reduce ester. Ester को reduce करना है तो we can use this. Further, it will not reduce alkene and alkyne. No reduction. But alkene or alkyne को reduction करना है तो we can use palladium charcoal, as we have seen in the previous slides. So sodium borohydride is a chemoselective reaction. I told you there are three types of selectivity: enantioselectivity, regioselectivity, chemoselectivity. Enantioselectivity or stereoselectivity or diastereoselectivity, where basically stereoisomer is concerned. Regioselectivity is the place we have visited this thing called Sadzev rule. दो alkene में से किस alkene सबसे ज्यादा बन सकता है? That is regioselectivity. यहाँ पे कीमो सेलेक्टिविटी है। कीमो स्टैंड्स फॉर फंक्शनल ग्रुप। दो फंक्शनल ग्रुप है, एक कीटोन है एक एस्टर है, तो दोनों में से किसको रिड्यूस करके कर सकता है उसको बोलते हैं फंक्शनल ग्रुप सिलेक्टिविटी। दूसरा नाम कीमो सिलेक्टिविटी। So we can use the sodium borohydride to reduce ketone to alcohol. And if we have ketone and alcohol, it will selectively reduce more this sensitive substance, that is alcohol. So basically ketone and alcohol है, और फिर आप sodium chloride use कर सकते हो. तो if we change the conditions using sodium chloride, then now it will reduce this. So these are all catalysts and reductions, and the session today we learn the reduction. In the next session we will learn the reverse of this. आज हमने सबको reduce किया है, अगले session में इनको oxidation करेंगे. Opposite to reduction is oxidation. So we'll learn that into the next slide. We'll stop up to here, and thank you all.